Okay, good morning, folks. We'll just get started. Thank you for joining, everyone. I'm Danielle Edwards, and I work for SCAMP. And this is a webinar put on in partnership with the California Housing Partnerships Build program and the Association of Energy Affordability. It should be a really great session. We will be sharing out a recording link and the slide deck after the session, so look out for an email later today from me with that information. And I'm just gonna go let Ian and the team get started. So, Ian Sharples will get this started off.
Hi, welcome all. Looks like we still got people coming in like once a second. Very cool. So howdy, my name is Ian Sharples. I am a sustainability program manager at the California Housing Partnership. My main role is working on implementation of the BUILD program, which is a California Energy Commission program for uh, all electric new construction. We have a really in-depth program today for you on heat pumps. They are a emerging technology for decarbonization and just generally reducing energy bills, which is something that is on the mind of a lot of affordable housing providers these days. So, with that, I think it'd be good to introduce a little bit about the panel and the build program. Just a note, we do have time for Q&A, so please put your questions in the Q&A box. It's down here at the bottom, I think over this way, yeah, of the Zoom. So you'll be able to get those questions answered at the end of the program. So please make use of that. There's also the chat if you want to chat amongst yourselves. But with us today, we have Ari Usher. Ari is a project manager for the Association for Energy Affordability. Ari joined AEA in 2022 as a senior associate. She is passionate about working with like-minded individuals on energy efficiency and electrification in the built environment. She brings over 10 years of experience working with local governments, utilities, building designers, and community members to increase environmental sustainability with a focus on design review, construction administration, and education within the building design and construction field. So we'll be talking a lot about that today. Ari has a BA in environmental studies and is a certified energy analyst and certified green building professional. So very knowledgeable about the topics today. We also have David Avna. David is a program manager at the Association for Energy Affordability. David is responsible for managing new construction incentive programs that include the Building Initiative for Low Emissions Development Program, that's BUILD, the Clean Energy Homes Program, and California Electric Homes Program. So very knowledgeable on the program side for David. These programs serve as catalysts for market transformation across the various regions of California, and they incentivize improved all-electric design for both affordable and market-rate residential multifamily buildings. So before we get into the core of the heat pump program, I'd like to introduce a little bit about the build program since all three of us work on this. It is a California Energy Commission program that incentivizes all electric new construction for affordable multifamily properties. It's really intended as a market transformation program to bridge the gap from the electric ready present that is mandated in the current energy code with the anticipated all electric future that will be coming down the pipeline soon. So smart developers are getting on ahead of the curve now with programs like Build. And this is really intended to help make the clean energy technologies of the future accessible to residents in affordable housing developments across California. So, a little bit about what Build provides. Build provides 300 hours of no-cost technical assistance. And this is really meant to build the in-house capacity for all electric building. So, a lot of things they can help you with are design review, just general knowledge about best practices for electrification and decarbonization, helping equipment sizing and selection, especially for things like heat pumps, like we're going to be talking about today, and generally any sort of design or energy efficiency question that you might have as it relates to your new construction. Build also provides up to $2 million in incentives for affordable all-electric new construction, as well as a special new adopter incentive for $100,000. And that's if you're building your first all-electric multifamily affordable property, you can get that extra incentive. It's really encouraged to layer Build with other programs and other incentives. It plays well with others. And You're also looking at a long-term reduction in utility costs, which is something that a lot of people have been searching for ways to do, especially with rising rates across the utilities in California. So if you're looking for, the long-term savings as well as some upfront incentives, Build is a great option for that. So with that, I want to hand it over to my colleagues. I think Ari is going first, and then I'll be handing it on to David. So thank you all, and enjoy the show.
Thank you, Ian. I'll take it from here, actually. All right. So I wanted to give a basic rundown, fundamentals to make sure we're all on the same page of what are heat pumps. And so we'll go through the basics of heat pumps, and then we'll start getting a little bit deeper dive with Ari after this. So next slide, please. So what is a heat pump? A heat pump is a device that moves heat from one place to another using refrigerant. You already use a heat pump on a daily basis. Your refrigerator is a heat pump. It uses refrigerant inside the coil to move heat from inside the refrigerator into the kitchen. And that's why you feel heat around the refrigerator towards the back or the bottom, depending on where the coils are located. A water fountain that dispenses cold water does the same thing. It takes heat from the water to cool it down and exhausts warm air from the grill. A window unit AC is moving heat from inside your home outside. A heat pump water heater that we'll talk about later is a unit that moves heat from the surrounding air into the water and exhausts cool air. So all these things are heat pumps. You've been around them in your everyday life, but we'll get into why uh, these heat pumps are different that we're talking about and kind of how they work and how they have different applications. Uh, the next slide, see how it actually works. This is a diagram of the cycle of what happens in a heat pump. Towards the top of the diagram, there's a compressor that's compressing the refrigerant that allows it to release heat. Then towards the bottom, there is an expansion device that lowers the pressure of the refrigerant, allowing it to absorb heat. And this happens over and over again. So as it releases heat and absorbs heat, it can move uh, that temperature from one place to another. So this allows heat to be moved from inside to outside or vice versa. Next slide, please. So what's so great about heat pumps and why are we talking about them today? Well, they're 3 to 5 times as efficient as electric resistance or gas, and they move heat rather than generate heat through fossil fuels. Unlike propane or gas appliances, they enable zero emission buildings. They can improve air quality because there's no on-site burning of fossil fuels. We do not have any gas lines needed, so it reduces the hazards associated with that. They provide heating and cooling in one system, and they can work in many different climates. Next slide. So these aren't your parents' heat pumps, right? The good thing to know is that heat pumps can operate in different climates, even in areas that fall to negative 13 degrees Fahrenheit. Although in California, specifically, the climate doesn't usually go this extreme. I'm mentioning this just to say that for some of the earlier technologies, they may not have performed as well in colder climates. Now they do. Now I'll hand it off to Ari to talk a little bit more in detail about the heat pump applications and how we can use them in different places in our home.
Thanks, David, for that great introduction and overview of heat pumps. So we're going to dig into the different equipment options that you have for meeting your building loads. So we're going to start with heat pump space conditioning. Um, and yeah, we've got here just some images of the different options for individual application. So this would be for a single space conditioner for each unit, sometimes called unitary or individual. Um, on the left-hand side, what you see is your ducted heat pump. It's got a kind of a boxy outdoor unit there, and it's paired with an air handler unit and ductwork that's going to supply the hot or cold air to your spaces. So this probably looks pretty familiar. It looks a lot like an air conditioner that, we may be used to. It's got that large outdoor unit that may be located up on the roof or maybe located on a concrete pad next to the home. But instead of just providing cooling, a heat pump, can provide heating and cooling based on the time of year. Um, and then let's move over to the mini split heat pump option. So these are also pretty popular, especially in multifamily applications. Um, the mini actually refers to the smaller form factor of the outdoor unit itself. So you can see there the kind of like suitcase rectangular shaped outdoor unit. It's quite a bit smaller than your traditional heat pump. So it's really great for saving space if you've got space constrained applications. Now, this can be either ducted or ductless. Refrigerant lines from the outdoor unit will, run to the fan coil unit, usually sometimes called the mini split head. And that's a ductless application, or it can be paired, with an air handler unit and then deliver conditioned air through registers. There's also a little picture there of a thermostat. So, just to call out that these units are controllable and they're also programmable. So offering a lot of technological bonuses if you go with that mini split heat pump. And the other thing to know about these units is they're highly efficient. When compared to a more traditional heat pump, they offer, you know, quite a big efficiency boost. And we'll get into that a little bit later. Um, so a great option there. These we've been discussing kind of split heat pumps where you've got an outdoor unit and then you've got an indoor air handler unit or fan coil unit. There are also packaged options where the heat pump itself and the distribution are in one cabinet. So I'm going to talk a little bit about those options. Um, what you're seeing first is a vertical terminal heat pump, also called a VTAC. It's a little bit of a larger unit, but it's got the heat pump in there and it's got your fan coil. And it does have a short length of ducting to provide the conditioned air. It also does have a wall penetration. So it does need to be on an exterior wall so the condensate can be and the outdoor air can be provided in. So it does have a exterior wall penetration. And there's another option for package units as well, called a package terminal heat pump, or also called a room heat pump. These are even kind of more space efficient than the VTACs. As you can see, they're can be quite compact. Again, these are packaged with the heat pump and the fan in a single unit. These are really great, again, for applications where you may not have a lot of area outside for an outdoor unit. They're really space efficient. Um, and, I will say that some of us may be familiar with PTHPs in a hotel motel application. There is a little bit of a conception of PTHPs or PTACs as noisy or inefficient, but that is no longer the case with all products out there. There are very efficient and very quiet room heat pumps available that use an inverter technology. So the kind of new era of room heat pumps are here. These are really great. What we see them in is typically smaller units, studio or one bedroom apartments. Um, because the thing about these is you do need one of these units for each of the spaces that you want to condition. So if you're looking at a larger apartment, it's like 3 to 4 of these room heat pumps. So we do really see these for smaller units and apartments like that. But the other good thing about these is you do have room by room control. Each of these units is individually controlled. So you can be very efficient in providing conditioning only where you really need it at that time. And yeah, just, remember as always with heat pumps, you get space heating and cooling in a single piece of equipment. So with kind of the rising temperatures across the state, this is a really big benefit. Transitioning from gas furnaces or gas heating to heat pump heating and cooling is a large benefit to residents. Okay, so that's individual systems. And let's also talk about central systems. Again, you do have the ability to use heat pumps to provide space heating at a central level. We usually don't see central systems providing um, space conditioning for dwelling units. This is more typical of, in a multifamily application, um, to condition the common areas or the building services areas. And of course, these are going to be common also in commercial or industrial buildings, but we are focusing on housing today. So I am going to take us through these different system types. There's actually quite a few different options for central space conditioning with heat pumps. Um, it's very similar to, the concept that we discussed before, but it's just a larger capacity heat pump that's then paired with fan coils at each of the spaces that you want to condition. So first I'll talk about variable refrigerant flow systems, also known as a VRF system. The great thing about these is, so again, you've got your larger capacity heat pump, could be usually located up on the roof. And then you've got refrigerant lines to each of the spaces that you want to condition. The great thing about a VRF system is it does have the ability to provide simultaneous heating and cooling to the different spaces, depending on what's needed. But the thing to really consider with VRFs is it's quite a bit of refrigerant in that system. You've got, all of the lines to the different spaces. And so when we're thinking about operations and maintenance, VRF does need to be checked. The refrigerant may need to be topped off, and that any refrigerant leakage is just, in the nature of equipment. There's going to be a bit of refrigerant leakage with a VRF, since you have so much more refrigerant in the system, the leakage is just that much more. So just something to consider when you're thinking about your different options. All right, then we'll move on to a packaged rooftop heat pump. This is a larger capacity heat pump again, and it's combined with an air handler unit. And then there will be ducting to the different spaces that you want to condition. Yeah, we see these often for example, like community rooms, kind of larger um, common areas in a apartment building application. Um, and then I also wanted to kind of go over dedicated outdoor air system. So for folks that aren't familiar, dedicated outdoor air systems or DOAS systems are typically used for providing fresh outdoor air to typically the corridor spaces in a multifamily building. Um, that air usually isn't going to be conditioned fully up to the temperature that you would have inside an apartment, but it does need to be tempered to slightly take the chill off in the winter or slightly cool it down in the summer. So, in a mixed fuel application, you'll see a DOAS with a gas furnace in there. But I just wanted to bring it to your attention that there are DOAS equipment out there that has heat pump in it. So you can do your air tempering with a heat pump as well. Great. So we've been talking about air-to-air heat pumps. If you remember back to that diagram, we've been talking about the refrigerant is taking heat out of the air, and then it's actually transferring it to air, which is then supplied to the spaces. But there are also air-to-water heat pumps out there that can be used for space conditioning and specifically space heating. These units actually, remove heat from the air and they transfer it into water. And then heating is provided via hydronics. So you'll pair one of these air to water heat pumps with a hydronic fan coil, or you can pair it with a radiator or hydronic floors. So in this way, water is actually the mechanism for moving heat around the home. And the cool thing about these systems is they are actually a combined system. So they can provide water heating as well as space heating with one piece of equipment. Um, in the individual application, there are actually a lot of these coming to the market. This is becoming a more and more popular piece of equipment. So just wanted to call out that some manufacturers that have products either already available or coming soon from Daikin, Hisense, Gree, Samsung, Space Pack, LG. So there's a lot of these coming onto the market. And again, these are pretty cool. You can provide multiple building loads with one piece of equipment. It does provide your space heating, and it also provides your water heating. Now, the question is, what about cooling? So there is an air to water heat pump application that does also provide space heating, water heating, and space cooling. So you can see over on the right side, this is a central application. It's a heat recovery chiller. This is a really highly engineered system, but it can provide space cooling through chilled water along with your space and water heating. So this is more of we don't usually see this in a multifamily application in California. Sometimes for very large buildings, you'll see this. But I just did want to mention that this equipment is out there. So let's talk a little bit more about the efficiency of these space conditioning heat pumps. So just a little teaser, because I do want you all to benefit from Build TA and come to us and get a TA case. But just a little teaser on how to get highly efficient space conditioning heat pumps. I talked before about the difference between a single stage and an inverter driven heat pump. So it's always important to consider inverter driven heat pumps rather than single stage heat pumps. This is going to increase the conditioning efficiency. You can see, you can see on the graphics here, I've highlighted the efficiency here. So for your single stage heat pump, the efficiency is 14 SEER. That's a minimum efficiency. That's federally mandated. That's, the barely minimally compliant system there. When you go over to an inverter driven heat pump, you see that the SEER is up to 18 SEER, and there are products up there up to like 25 SEER. So the efficiency boost is pretty big. And let's talk a little bit about what's happening here. So when these systems are sized, they're sized based on the hottest day and the coldest day of the year, right? Because you need to provide heating and cooling when it's really cold outside in winter and it's really hot outside in summer. But for most of the year, you're not going to need that full capacity. With a single stage heat pump, it's sized to meet the maximum need, but it doesn't have any in between. So that means for most of the year, it's going to be short cycling. It's going to be turning off and on very quickly and rapidly. And that can cause, in addition to decreased efficiency seen by this efficiency rating, can also cause wear on the system itself. So an inverter, what it does is it allows the compressor to change speed and capacity. It can scale smoothly to meet the needs of the building. So compared to a single stage, which will turn on and off rapidly, the inverter-driven heat pump actually stays on at a low level and just scales up or down to meet the load. And that is what is giving you the larger efficiency there. So yeah, inverter driven sometimes has a price premium above single stage, but it does have those cost-effective savings over time. And they're available in ducted, ductless, and packaged options. And another thing to note is these units also offer a lower decibel rating compared to single speed compressors. So yeah, with that, let's go on to water heating. Now, I know a lot of folks are probably pretty familiar with space conditioning with heat pumps. At least it's been around for a number of years. Heat pump water heating, I think, is a little bit newer to the market. The market is still really transforming so to where heat pump water heaters are very common. But this is the way to do water heating in an all-electric application. So let's get into it a little bit. This is just returning to the refrigerant cycle diagram that we saw earlier. Just wanted to revisit it a little bit to kind of show that there is a heat pump, and the heat pump is then going to be paired with hot water storage. So the idea behind heat pump water heating is to have quite a bit of hot water storage. And the heat pump itself, is actually an air to water heat pump. It's absorbing heat on the hot side of the cycle, and then it is expelling heat into the water on the other side of the cycle. What I'd like to also point out here is that heat pump water heaters do exhaust cold air, right? So as heat is removed from the air, then the output from that system is cold air. And we'll talk about that later, but just wanted to put that in your mind. All right, so just briefly, when we look at a typical gas water heating system, you've got a gas boiler and a storage tank as well, but you're required a larger BTU and a smaller storage as compared to a heat pump where the design really requires a smaller BTU, but a larger storage tank. So let's take a look at this equipment here. This is again for an individual application. So you'll see these if you have a water heater for each of the homes, in either in a single family application or multifamily with individual water heaters. And again, we see that we have a split option and we also have an integrated option there, integrated or packaged. But the concept is still there. You've got the heat pump itself, and then you've got the hot water storage. So let's look at some pictures of installations. And what I really want to highlight here is a couple of things. So again, these are your individual water heater applications. Pretty typical for an installation would be having these installed in an outdoor closet. But I do want to mention here that ventilation and ducting is really important. So as I talked about before, these heat pumps, they do exhaust cold air. So you can see on the photo on the left, there is a run of duct, and this is actually connected to the exhaust grill on the water heater. And it's actually removing that cold air out of the closet itself. So you can imagine if there wasn't ducting there and you close the closet door, as the heat pump is running and as it is extracting air or heat from the air in that enclosed space is going to really cool down. And then what happens is the efficiency of the heat pump itself will tank. So you're depleting the heat source if you close the closet door and you allow the heat pump to run, and you will see an efficiency decrease. So that's why ducting is really the best option for ensuring heat pump efficiency. You can also do it unducted. That's totally fine. You just have to, in that case, make sure that you're providing adequate ventilation so that warm air gets into that space. So on the picture on the right here, you see a line of ductwork. That's actually not for the water heater. That is connected to that air handler unit right there. The water heater itself, you can see the exhaust grill, which is kind of that circular piece of louvered metal there on the water heater. It's not ducted, but this door itself would need to be fully louvered. And then that's going to allow enough ventilation to ensure that the water heater is performing. All right, now what about central applications? So for multifamily buildings, we do see a lot of central heat pump water heating plants. And I think the thing to understand from this photo is there are quite a few different products out there. Even just a few years ago, there may have been fewer products in central heat pump water heating, and even fewer still that were certified and allowed to be installed in the state of California. That's not the case anymore. There are a number of different products out there. And more than that, even there are a variety of form factors and capacities, from smaller capacity heat pumps to medium capacity to quite large. So whatever the application, there is a central heat pump water heater product that can work really well for your project. Um, and there's also a product in the central realm that is an integrated tank. So, what we're seeing here is just the heat pumps on the left there. And then on the right is an integrated tank product. It's similar to those, individual heat pump water heaters. It's got the heat pump and the storage tank there. But that's only one product. So most of the central applications, you are going to see your heat pump, and then it is going to be paired with storage tanks as well. Let's look at a couple photos. What's important to note here is, again, the flexibility of these central heat pump water heater plants. It is a built-up plant, so all the different components are put together to create the plant, and you can locate the tanks and the heat pumps wherever it makes the most sense for the project. On the left, you're seeing this is up on a roof. This is a pretty good option for your water heating plant. Having the heat pump located outdoors allows for plenty of ventilation for the heat pump itself. You can see the heat pump and then the storage tanks as well, right next to each other on the roof. And then just off screen, you're also going to have the mixing valve and the recirculation pump in a weatherproof enclosure. And then over on the right, here is an installation where they actually have the storage tanks and the heat pumps in different areas. So you can see the large storage tanks. These are located in probably a mechanical room of some kind. And then the piping goes over to the heat pumps, which are installed in the garage. And what I also like to note here is these are actually wall mounted. So, they didn't have to use up parking spaces with their heat pumps. They actually were able to mount these up on the wall, um, um, which also has a benefit of, moving them up out of the way so they're not going to get damaged or messed with. So this is a really great option. You got your heat pumps mounted on the wall, connected with your storage tanks. And you can also see on that lower photo, you also have your mixing valve and your recirculation pump. And also you can see a swing tank there as well. Yeah, so we talked about efficiency for space conditioning. I also want to talk a little bit about how to choose efficient and high performing products on the water heating side. Um, the Northwest Energy Efficiency Alliance, also called NEA, maintains an advanced water heating specification and qualified product list. This is a really good resource for anyone looking to spec heat pump water heaters. I know it says Northwest Energy Efficiency Alliance, but the specifications are actually built for water heaters across the nation. So this is really the resource that folks use. The specifications have a number of different fields and criteria, and then they will rate heat pump water heaters in all these different fields. So when you go to this resource and you look at the qualified product list, you're going to be able to see how the product performs in all of these different areas, and pick a really good one. On the residential side, they have specifications not only for energy efficiency, but also for electric resistance backup, and demand response, sound level, condensate management, airflow, warranty, and product documentation. And on the commercial or multifamily side, they've got criteria for standards and approval testing, for performance, for vendor provided guidance, qualified piping configurations, optional demand response capability, and system efficiency tiers. So yeah, use this resource to identify the highest performing products that are out there. And with that, I'm going to pass it back to David to talk through our Build Technical Assistance offerings.
Hi. Uh, Thank you, Ari. Next slide, please. Okay, so yeah, Ari talked a little bit about external support for equipment selection, but our team can also provide that sort of support as well. The Build TA team has very experienced people in residential low income all electric construction in California. So all the folks on the TA team, the technical assistance team, have gone through the process of learning the hard way. So let us share those lessons with you and help you develop an electric building with support. Some examples of what we can help you with are we can work with your architect on space planning. So are you going to have to install larger electric service or transformers or other electrical equipment that you don't usually install? We can help plan out those best locations. We can work with your mechanical engineers on heat pump water heater design, both in unit and central systems. We can work with you on increasing energy efficiency in general in your building. We can help with equipment selection, as I mentioned earlier, and we could even help with local permitting questions. Next slide, please. So as part of our service, we can take you from intake as far as to building completion by providing you with up to 300 hours of free technical assistance. We can help determine your eligibility for the build program, refine your design for maximum incentives, and support you in preparing the incentive application for the program. We have lots of experience with incentive programs, and we can help guide you through this participation and participation in other programs as well. Technical assistance is available to every eligible applicant. You can receive support education without having any specific project in mind as well. So any eligible project team, regardless of experience with all electric, should be able to participate in this program and be successful in developing all electric buildings. Next slide. One of our primary technical assistance offerings is a design review. Our review includes project-specific recommendations of opportunities for energy efficiency, health and safety, and system operations. The members of the build team have years of experience with building electrification. We have been involved in many first of its kind installs across the state and have learned some valuable lessons. This has the most impact once full drawing is set up, uh, but was but still during the design phase or so that changes can be made. So, you know, we could work with you with a full plan set or even just initial design phases early in the pre-development. That said, we do encourage design reviews even for projects that are permitting or even in construction right now. You could apply those recommendations to other projects in your portfolio or just simply have it as a good recommendation to keep in mind. I'd also like to highlight that there are a lot of recommendations in the design review that we provide, but these are not, for the most part, requirements for the program or eligibility requirements. Uh, we certainly call out changes that need to be made for the build incentive eligibility, but the majority of the recommendations are opportunities to make an already compliant building even better, and to introduce project teams to new ideas that they may not have been aware of in the past. So while all the recommendations may not be implemented on a specific project, we like to think of our design review as a conversation to inform future projects. This is all about market transformation. Next slide, please. Okay, so now we'll get into a little bit of operations and maintenance. Next slide. Regular maintenance, very important. Please make sure to schedule and conduct regular maintenance. It's essential, especially for heat pump water heater systems. Ensure on-site manuals and service schedules are provided to your maintenance staff. Troubleshooting. The same concepts do not apply for heat pumps or heat pump water heaters specifically, and combustion plants. Maintenance contracts with installing contractors are often available and highly recommended to provide ongoing support to building management. Our TA team can also come out on site and conduct performance verification checks to make sure that your new building is operating as it should be. Next slide. Building maintenance training. On-site training can often be provided by installing contractors and is essential for supporting a high-performance building. Consider providing ongoing training resources such as our AEA's online learning management system. We have a variety of different courses free for any contractor, so please reach out to us so we could help support more online training for the facilities management staff. Also, resident education is key. Responding to tenant complaints in a timely and sufficient manner is important and can reduce negative impressions of heat pumps and all-electric building technology. So consider hosting community events, creating education resources for unit turnover, and I'll talk a little bit more in the next slide about more ideas for tenant education. But key thing to remember before I get to the slide is that your all-electric building is likely has new assets to your residents and maintenance staff that they may have not interacted with before. So new assets means new strategies, and education is going to be critical. So for resident education, consider providing resources to the residents about a variety of different topics. And this applies to HVAC, to appliances, as well as hot water and any building level systems such as solar PV or batteries. Uh, by providing this education and teaching the residents about how their building works and what kind of equipment has been installed, it can help instill a sense of community and pride for residents, which then will support the ongoing maintenance of these products because they'll have a little bit more knowledge about them and likely respect them a little bit more as they learn more about them. Resources could also be included into welcome packet for new tenants or turnover. You could provide online resources such as videos or fact sheets, permanently installed signage inside or outside of the unit in the common areas, and also having community events are all incredibly helpful to help provide education and instill that sense of pride for the community. So for example, you could provide a fact sheet of how to use your smart thermostat. You could provide a fact sheet on how to use your new space conditioner because they may want to have it off at all times except for when they need it. But now for heat pumps, you want to have it slowly throttling constantly to keep that a temperature constant in your home. So the behavior is a little bit different between all electric equipment and uh, less efficient electric equipment like window AC units or even gas furnaces as well. Um, and you could also provide further education outside of specifically heat pumps. You could about conserving water and general energy efficiency recommendations that your company or your development may want to recommend to residents. All right, so that was a mouthful. Uh, so thank you for that. I want to open it up now, or rather pass it back to Ian, but this is part of our Q&A session now. There's plenty of questions in the chat. There's plenty of questions in the Q&A section. So yeah, let's get going.
Yeah, it looks like we've got some really good questions here. Basically split up into kind of heat pump questions and then some program questions. So I'll try to do the heat pump ones first, and then looking at the build program related ones. So let's see. So we've got here an anonymous attendee asking, what size of a unit is an issue for a ducted heat pump? Are there condenser units similar to the size of in size to a mini split unit?
Yeah, that's a great question. Yeah, mini splits are also the mini, right? Refers to also the very small capacity that they go down to. So you can actually get like a half-ton mini split unit. Um, so yeah, that's a great question. Yeah, your ducted heat pumps really, you do see those for kind of larger units, typically, not usually for like a single bedroom or a studio. But even a large two-bedroom or three plus bedrooms, that's a pretty good application for a ducted heat pump. I think the other thing to always really consider if you're going to do a ducted heat pump is, if possible, zonally controlling that is going to also allow for reducing energy use overall because you want to make sure that each of the spaces can be turned off if it's not being used. Um, so yeah, does that answer the question there?
I think so. Matthew Epstein has kind of a broader question. In kind of the simplest terms, why is a heat pump a benefit over gas heating?
Yeah, so a number of reasons. I think the first being energy efficiency. We kind of talked about in the beginning. A heat pump has a 3 to 5 times more efficient than gas heating. With gas, you're using the gas to actually heat up the air or the water. You can really only get as efficient as 100%. Usually with gas, you get, maybe 95, 96%. A heat pump, since it's really just using energy to move heat around, the efficiency is quite a bit more. We do heat pump efficiency typically in coefficient of performance or and those are up to 3, which is essentially like 300% efficient. So that's one reason. The other really is providing carbon-free space conditioning and water heating. When you use all electric heat pump equipment, when you pair that with renewable energy generation at the grid level, then you have carbon-free energy use in the home. So it really is a big climate benefit, which is, I think, a pretty impactful kind of reason. And then the other thing is, if you're thinking about space conditioning, and specifically if you do a gas furnace, but you also want space cooling, then you need to have an air conditioner as well. Um, Two different pieces of equipment. A heat pump offers space heating and space cooling within a single piece of equipment. Um,
Cool. Jonathan A asks, what is an air handler? Is DOAC one type?
yeah, an air handler is basically a fan in the most simple terms, it's a fan that moves the air over a heat exchange coil. So when we talked about, the heat pump using a refrigerant, it gets a highly heated refrigerant and it brings that to a heat exchange coil. The air handler will move air across the coil and allow for heat exchange into the air itself. So if you're trying to heat up the air, you've got hot refrigerant, air blows over the coil, the air is heated up, and then the air handler, then distributes that air to the different spaces via ducting. Um, and so in most simple terms, it's a fan. And then if you're cooling the space, you've got highly cooled refrigerant in the coil, and you blow the air over the coil again, which actually pulls heat out of the air into the coil itself. And then that air is distributed to the spaces.
Hmm. We have an anonymous attendee asking, why are air to water systems becoming more popular?
Yeah, that's a good question. It's really a lot about just that this is that heat pumps are becoming more and more popular and more in demand, and then manufacturers respond to that demand. So in the advent of all electric buildings, there are technological advances happening all the time with regards to refrigerants. So you really need to have a specific quality of refrigerant in order to provide the correct amount of heating to provide hot enough water that can satisfy hydronic heating through water. So it's really about the technology becoming advanced enough and the refrigerants available on the market becoming advanced enough to provide that adequate water heating for space conditioning.
Yes. Um, Last one in the Q&A box, but are any manufacturers trying to combine heat pump water heater cold air exhaust with their heat pump space cooling so you don't waste the cold air as exhaust? Is anyone
Yeah,
find that out?
that's an awesome question. And yeah, there's a couple of different applications to potentially do that through ducting design itself. Um, I don't know of any manufacturers actually trying to use the cold air exhaust for cooling. On the other hand, there are products that use hot air exhaust when actually cooling, providing space cooling. There is going to be hot air exhaust from that is then used to preheat hot water. So when we talked about our heat recovery chillers, that's exactly what that equipment is doing. It's using the heat exhaust from space cooling to actually preheat the hot water.
Cool. Got a couple related questions in the chat here, so I want to group them together. One from Janelle Miller and the other from Rich Wallace. Have the PTHP units replaced the PTAC units? And Rich says PTACs that we use allow for transfer fans to heat adjacent bedrooms. Does that go away with PTHP? So kind of asking about those technologies specifically.
Yeah. Um, Sometimes folks refer to use PTAC to refer to like PTHP that we discussed. The real difference is just PTHP package terminal heat pump has cooling and heating, whereas PTAC technically is package terminal AC, only provides cooling. So it's just a little bit of a terminology there. But when we're talking about PTHPs, yeah, you can use transfer fans. That's something that we do see. So just depends on what you're looking for your project.
Yeah. Karen Flock says, if water is hard, you need a water softener. Are there any sort of water softening considerations that developers should keep in mind when considering heat pumps, especially heat pump water heaters?
Yeah, that's a great point. Water quality is really important. Testing and determining if you do need a water softener for the system based on the water quality. The other thing is when we talk about maintenance, the storage tanks themselves have an anode rod, which is going to actually help to keep the water a little bit softer itself. So, if you do have quite hard water, it can build up and it can cause issues with the heat pump. So it's really important to be considering. If not a water softener for the system, there is recommended regular maintenance to replace those anode rods and then to flush the system periodically as well, which will also help to reduce scale buildup. So it really is a question of, regular maintenance.
Cool. Looks like most of the rest of the questions are about the build program. To follow up on the first mini split question, I noticed Matthew Epstein, including in the chat, you need little mini splits for small rooms that require conditioning, like elevator control rooms and fire control rooms. So definitely an important point to consider. So let's see what do we have here. Kind of moving on to the build program. Is technical assistance only available for new construction? I can kind of cover that. So build is available also for extensive rehabs. Technical assistance will be available for that. That is if you're tearing down more than 50% of the exterior weight-bearing walls, then would qualify as an extensive rehab. There's also technical assistance available in other programs for rehabs. I know LIWIP, I think EBD will be having that. SOMA also has some technical assistance. So there's a lot of different avenues besides just build where you can access that help, especially if you're looking at rehabs instead of new construction. So Janelle Miller asks, what is the manufacturer warranty on the specific equipment? Is there like kind of a general guide on what sort of warranties you should be looking at for this type of equipment? I don't know if you'd know that.
Yeah, I mean, I'll just kind of, and this isn't a super specific answer to the question, Janelle, apologies, but, kind of as a rule of thumb and general guidance, it is important to review the warranties that are coming with the equipment, and also review kind of the post-installation support that may be available from the manufacturer, in choosing your equipment. Those are important things to consider so you do have that ongoing support. if you have specific questions, we'd be happy to talk with you if you want to submit an interest form and look at, different equipment and look at what kind of warranties they offer. We can do more of that later.
Yeah. Pat Split asks, is there a minimum number of units required to qualify as a multifamily building? Think
Yeah,
the
I believe it's five. Yeah.
Yeah, I think generally five, and that'd be the threshold that's needed for the new adopters incentive. Although build is also still available for duplexes and fourplexes and single family as well. So if you're worried about maybe your project is too small for build, definitely don't worry about that. Let's see. Good question from Glenn Folland. How does build work with CETA?
Oh, Build and CETA. So yeah, another great program out there for new construction. CETA specifically does high rise, 4 stories and above. It is 100% layerable with Build. So yeah, we always encourage you to get both incentives and layer them up.
Cool. Theo Ham asks, can you talk more about the build incentives? Yeah, so the build incentives are there's four components that go up to make the total incentive. There is the base greenhouse gas reduction incentive. There's a energy efficiency incentive based on how efficient you are above code. There's a PV incentive for how much solar you're installing above code. And then there's the kicker incentives that are based on specific dollar amounts for specific technologies. Like a smart thermostat is like $50 per thermostat that you install. There's a good kicker webinar floating around out there. I think it might be on the CEC website, a link for that. But I don't know if you have anything else to add, David or Ari.
Well, I mean, one more thing would be actually the new adopter award, right? So it's an additional up to $100,000 for any developer that is developing their first all-electric new construction affordable housing project. So, uh, yeah, plenty of incentives available for folks, and it could be layered onto other programs as we just mentioned.
Very cool. And I think we got the last question just about in time. Yeah, well, next to last, Janelle asked, can this presentation be available to us for reference? Yeah, I do believe Danielle is planning on sending that out to the attendees today. But last kind of more technical question, Ismar Enriquez asks, will the program include preparation for upcoming code changes, such as fire rating and new refrigerant that may require more energy? So kind of generally asking about code changes coming up in that's the new year, yeah. Would be
Yeah, yeah, coming
Yeah,
up January 1st, 2026, new code. So yeah, be ready. We can help support with that.
yeah. So definitely for sure. I also want to plug that just because Ismar, you mentioned fire rating. uh, We are also coordinating with other programs under the TPC and CEC for those affected by wildfires. Obviously, in particular, those in SoCal and Los Angeles, Greater Los Angeles region. So, um, if if you have any questions about how new construction can be incentivized through programs like Build, as they were affected by wildfires or any sort of natural disaster, please also shoot us an email, submit a TA application, and we could support that as well.
cool. Well, thank you everybody. Really great questions. I appreciate it. So I'll hand it back over to Danielle to close this out. Thank you all.
Thank you, Ian, David, and Ari, for that wonderful presentation. As Ian kind of mentioned, I will be sending out the slide deck and a link to the recording of this to everyone who registered for the session. So you should be receiving an email before the end of the day today from me. So check your inbox from that. And thank you so much and have a great rest of your day.